In our lesson today, we do, as I said earlier, have a lot going on. We have 3 different topics that really don't have anything to do with each other. We are going to have a new formula for getting the area of a triangle. So from now on, you will have a choice. Area equals 1/2 base height or the new formula, depending on what information you are given. We will also be talking about what in the world is a segment of a circle. We know segments of lines, but what's a segment of a circle and how do we get the area of those? And we will be talking about systems of inequalities. The final one is largely a review from last year. So first, let's talk about the area of this trapezoid. And we have a formula for the area of a trapezoid. Who can remind me what that formula is? Charlene? So I think I'm going to write that with a half out in front. But for that. So now let's look at this trapezoid and let's start filling in what we know. We know what? The half, but what else do we know as we look at the pictures? Do we have base 1, base 2, and height, or just some of those, Marielle? So I can plug in that one of my bases is 13 and the other one is 8, but not the height. So the height would be right here. It is not 13 minus 8. That's what they thought last period for this piece of the triangle. I don't know that side, do I? If I took 13 minus 8, I'd have that green part plus this other green part. And that's not the green side of the little triangle on the left. I can't just say 13 minus 8 divided by 2, because are those 2 pieces congruent? There's nothing in here that says we have an isosceles trapezoid. So I have a triangle. I've had some where I've needed to find the height, and I've been able to use Pythagorean theorem to figure out the height. Can I use Pythagorean theorem right now to get h? So I need another strategy. Look just at the little triangle. I've got 26 degrees. I've got 6 meters. I've got h, and I've got a green side with nothing labeled. What can I do, Kyler? So I can write down that the sine of 26 is what? H over 6, everybody good with that? Which means the height is 6 sine 26. I'm not going to punch that in my calculator. I'm not going to store that and use a stored value. I am going to then go ahead and write that over here. So then what I can enter on my calculator, 13 plus 8 is 21. Everybody good with that? Will you let me get away with a half times 6 is 3? You could type it in a half parentheses 13 plus 8 times 6 sine 26, or you could type it in a half times 21 times 6 times sine 36, or you could type it like this, or you could type 63 sine 26 and should get the same thing no matter which way you do this. And I want to see hands going up when you have an answer for me for what this area of this trapezoid would be. So if you are not actively typing, that means I can call on you and you can give me the answer of what we get. Shayla, what do you have? Anybody else? 27.617. So I'm seeing thumbs up and some heads nodding. Units are meters. Area is meters squared, and that is our area. There is no shortcut formula for this kind of trapezoid problem. We'll get one for triangles next. But for this kind of trapezoid problem, it's got to be 1/2 base 1 plus base 2 times h. Show the work for what h is, and then write it over there. But you don't need to punch it in separately. Get where you can just punch it in all at once. Questions with trapezoids? Okay, now let's do a triangle one. And we are used to area of a triangle is 1/2 base times height. So we could say that the area is 1/2 times the 16, but we need to figure out the height. And we're going to do that very much like what we did in the last example. We don't have the formula yet. We're kind of deriving it here. Who can tell me how we would get the height? Much like what we just did in the trapezoid. I can't use the Pythagorean theorem. I know the 12 and I know the h. Thank you, Sarah. So if the sine of 42 is h over 12, that means h is 12 sine 42. So I can put the 12 sine 42 right here. And now you guys are going to help me punch that in on the calculators. You may punch it in exactly like that. You may do some mental math if you prefer. You can say a half times 16 is 8 and just punch in 8 times 12. Or if you can quickly mentally do 8 times 12, you can punch that in times the sine of 42. Do not do just sine of 42 by itself. Go ahead and put that in this formula. And then I want some people I can call on for what would be the area of this triangle. Ada, what do you have? Anybody else got the same thing? So that is our area. Now let's look at the work that we just wrote down and see if we can make a guess of what might be a shortcut formula that we can then try to prove. To do this, I said that the area for this triangle was 1/2, and this was one side, and this was another side. And for those two sides, 42 is the angle right in between those sides. So the sine of the angle between those sides. So maybe I can have a formula that says area is a half base times height, or if it's easier, area is 1/2 times one side times another side, if I have numbers for both of those, times the sine of the angle between those two sides. So let's see if we can prove that. So here's a triangle, much like what I did before, although I'm going to, I think, need to do this also when I have an obtuse angle in a triangle. So my first time here, I'm going to let this side be B just so it matches up with base. So I'm going to say I know two sides, if A and B are numbers that I know, and I know how many degrees for that angle in between them. I know that the area has to be 1/2 base times height. And I know that I could say that the sine of C is what letter over what letter, Maggie? H over A, which means that the height would be A times the sine of C. So if I plug that in, I have 1/2 times B times A times the sine of C, and my commutative property would let me switch that order. One side times another side times the sine of the angle in between. So with that acute angle, we just proved what we used on that last example. However, if I have an obtuse triangle, and I let that be my base, and this be my other side, and so C is now an obtuse angle, that means that my height has to be outside the triangle like that. And I am wondering if my formula will still work. I know that it still has to be 1/2 base times height. But to do SOHCAHTOA, I've got to be in that right triangle, not the obtuse triangle. And if this little part here is C, that means 180 minus C is my angle that's inside the right triangle. And let's see, then I could say that my sine of 180 minus C of this acute angle right here would be opposite H over A. So I could say this is 1/2 side B, but my H would be A, not times the sine of C, but the sine of 180 minus C. So I'm not quite getting the same formula. So far, are you with me? However, I want you to think about your unit circle. And I'm only going to worry about something like this, because if I'm dealing with a triangle, I'm not going to have an angle that's more than 180 degrees, and I'm not going to have an angle that's measured in negative degrees. But I could have any angle that's acute or obtuse in quadrants 1 or 2 for C. So then I'm going to draw a congruent angle right there that is C. So like 30 degrees and 150 degrees. What about their signs, their y coordinates? Mario? They're both the same, and with what I said, they'd both be 1/2. But in general, if I did a C that was a little bit bigger and a little bit bigger over here, would those also have the same y coordinate? So both of these spots have the same y coordinate. Now, normally we say that's C, and then we would say this much is 180 minus C. If I just looked at this C right here, this would be 180 minus C to make that be the whole 180 degrees, right? So from what you've told me of what you know about the unit circle, the sine of 180 minus C is the same as the sine of C. So I do indeed have the same formula, 1/2 one side times the other side times the sine of the angle in between, even though C is an obtuse angle for this triangle. So that's your next formula, to write down that the area of a triangle is 1/2 one side times another side times the sine of the angle in between. The critical piece is the angle has to be the one that's in between the two sides for this formula to work. That means if you are given base and height, use 1/2 base times height. But if you aren't and you're given two sides and the angle in between, use this formula. Use the one that has the fewer steps. Do not always use 1/2 base times height and rederive this formula over and over and over and over again. Everybody pretty much have that formula written down? I will get this back up in a few minutes if you didn't quite get it. In the meantime, I would like for you on your own to use this brand new formula and calculate the area of this triangle. You have all said you've gotten 53.623, which is indeed correct. So area is 1/2 one side times another side. The 130 is in between there. The sine of the 130 degrees. You could, if you wanted to, mentally do 1/2 of 14 is 7 times 10, 70 times sine of 130, or you could enter the whole thing. But you do indeed get 53.623 square meters. Questions from anybody on that? All right, then to transition to a segment, I want us to review area of a sector. A sector is a piece of pie. We are used to, we take the fraction, the number of degrees out of 360 times pi r squared. But if they give us the angle in radians, we don't want radians out of 360. Radians would have to be out of a whole circle of radians. Degrees is out of a whole circle of degrees. We have to keep the units the same. So if they give the angle in radians, we could just say the angle over 2 pi times pi r squared, and then your pi's will immediately cancel, and then you can continue to go from there. So if we want to talk about a segment of a circle, it's like the shaded part that I drew right there. So you take 2 points on the circle and you draw the chord that goes between them. and then you shade the little piece of the crust in between that line and the circle. We're only going to talk about segments when the angles are between 0 and 180 degrees or between 0 and pi radians. If it were an obtuse one, we would have a much fatter looking segment of a circle. So if we had an obtuse angle, if we connected those 2 points, do you see how that segment would be quite a bit fatter? Okay, look at either picture, look at both pictures, and just using shapes, describe for me how we might end up with just the shaded part. Maybe say this kind of shape plus that kind of shape, or this kind of shape minus some kind of shape. What shapes could you add or subtract to get that strange little shape that we are now calling a segment? I'd like to see a bunch of different hands going up. What can we put together? Francis, what do you think? Is everybody good with the sector minus the triangle would give us that shape? If we took the whole piece of pie and then we took away the triangle, we'd just have that segment. If you think it would help you to add that as a formula and a half or something, if you want to say the area of a segment, and maybe even draw yourself just a little sketch like that to help you keep straight what's what. And then, boy, I wrote that crooked, didn't I? Make that look a little bit better and more readable. You could simply say that it is the sector minus the triangle, if you think that would help you to also have that in your list of strategies and list of formulas and have the picture definition right there where it's real easy to see. You are going to need to be very careful reading homework problems from now on. Some of them, they will still just ask you for the sector, the piece of pie. Some of them, they will ask you for the segment, but read it carefully so you get the correct answer. So now we're going to practice doing that. I'm going to put some numbers in here on this picture. We know that our strategy needs to be our sector minus the triangle. They tell us that the radius is 8, which means this side is 8, but it also means we know this side is 8. And they tell us that the angle is 0.5 radians. So that's why we were reviewing the sector formula with radians. It is going to be 0.5 radians, not out of 360, but out of 2 pi, times the r squared, and r is 8. And then minus the triangle. Let's clean this up just a little bit because it's pretty easy to clean up. The pi's cancel. What's 8 squared? 64. What is half of 64? 32 times a half. Everybody good with the area of the sector is just 16? Okay, now for the triangle. We have a choice of 2 formulas. 1/2 base times height. Do we know the base? Do we know the height? No. Our other formula, 1/2, one side, another side, side of the angle in between. Do we know 2 sides? Do we know the angle in between? Did they tell us how big theta is? Yeah, they told us it's 0.5 radians. So we're going to do minus 1/2. One side is 8. The other side is also 8, times the sine of the angle in between, but it is in radians. What does your calculator say in the top right corner right now? Does it say RAD or DEG? So you have to do one of 2 things. You can put in a multiplier and change this to degrees, or what else could you do? Change the settings. Just get your little arrow To go all the way up there where it says DEG, click once and it should toggle it to radians. And then just enter all at once, 16 minus, let's go ahead and do this part mentally, a half of 64 is 32, times the sine of 0.5 radians. It's not wrong if you convert it to degrees, but it's a heck of a lot less work if you just click on degrees and change that to radians. And then as soon as it looks like people are setting down the calculators, I will get some answers from you guys of what do you get for this. Jack, do you have a number for us? Thumbs up, thumbs down, 0.658. That's what I have down here also. And our units were feet, so the area is square feet. So you see what we're doing with that. Anybody with questions up to that point? All right, then our final topic is reviewing systems of inequalities. And first we think about what kind of shapes would these be if these were equal signs instead of less thans, greater thans, or whatever we happen to have. The top one, if that was y equals a third x plus 3, everybody shout out what kind of graph is that? That one's a line, dotted or solid? Dotted. So 1/3 x plus 3. So draw these carefully because test point checks are going to be required. And if you draw a sloppy graph, you're often going to be picking points that are not in the region that you think is the solution. So draw a good graph, go all the way to the edges, up 1/3. And then you said I needed to make this be a dotted line. So there is my dotted line. In general, if you have a graph that is y is less than, you are going to want to be shading the part that is below that. And if you have a graph that is y is greater than something, your y coordinates are bigger than the line or bigger than the parabola, you need to do points that are up above the line or the parabola. So on this one, do I think I want below the line or above the line? Below the line, because it's really y is less than. So I think for this one, I want to be below the line. Now, what shape is the second one? It's a parabola, but it's not in vertex form for graphing. So I need to complete the square and get it in vertex form so I can draw the graph. I don't have to do all of the steps that I do when the problem just says graph the parabola, but I've got to do enough to get my graph accurate enough. So I'm going to start thinking of it as y equals, and then I'll change it back to greater than or equal. So I'm going to have the x squared plus 4x plus 2, which means I can immediately do a y minus 2 is x squared plus 4x, and then something else in there. Then I want to get, for completing the square, x plus or minus something. What needs to go in my little parentheses? Elena? Plus 2, I take half of what's there. And then if I FOIL that out, x plus 2 times x plus 2 is x squared plus 4x plus 4. So to make those two match, this needs to have a plus 4. Is that really a plus 4? Yeah, I didn't have anything I had to factor out in the beginning. So I have a plus 4 over here, which means I have a y plus 2 equals. So y is this minus 2. So, Austin, what will be my vertex for this parabola? So we're going to do a dot on that. That also means we have, this is our axis of symmetry. Does this one open up or down? Up, so when I draw it, it better be opening up. Let's come back to our original equation. What is my y-intercept if this is an equal? If x is 0, what's y? 0 plus 0 plus 2, so 0, 2 for my y-intercept. And so that means I can do the symmetric point over there on the other side. So my parabola is doing something like that. Are we agreed with that? Okay, this is really not y equals, but y is greater than or equal. Do I think that means above or below the parabola? So I think I need to be above the parabola, but below the line. Oh, by the way, I drew my parabola solid. Do I need to go back and change it? Should it be dotted? No, it had the or equals in there, so I'm correct to have that solid. So if I am over here, I am above the line, but outside is below the parabola. And that's not what I want. Notice if I wanted to talk about above the line and below the parabola, that would be split. I'd have this part over here and this part out here. If I wanted to do above the line and above the parabola, that would be this part from the dotted line up here, but staying inside the U shape. Everybody good with that? I could also have below the line and below the parabola, or the one I think I have here, below the line and above the parabola. If I were below the line and below the parabola, I'd have all of this out here. What we really have is below the line and above the parabola, so I'm going to shade in here. That is what I think is my solution, but I still need to do a test point check. I wanted to talk about the four regions. When you draw the graph, do not throw in A, B, C, and D. The book will sometimes give you the graph and the inequalities and ask you, would it be A, B, C, or D? One of those will be in two parts. And there's no rhyme or reason to it. It's not, this one is always A. Sometimes above the line, below the parabola is A, sometimes it's C, sometimes it's D, sometimes it's B. We'd all be picking different ones. So don't put letters on yours, just do the shading only on the part that's your solution. Then test point check is required. Just like last year. So first you pick a test point that's in the part you think should be shaded and write down its coordinates. Try to pick something easy. It cannot be on the line or on the parabola. It has to clearly be inside. What if your graph was a little bit off for one thing? I'm going to, and zeros and ones are always nice to pick if you can. So I'm going to pick -2, 0, just because I'm sure it's in that part I'm trying to shade. Write down the point you pick, show both checks. We need to check that in y less than 1/3 x plus 3, which means I need to put in the y is 0, 3 minus 2/3 would be 2 1/3. Is 0 less than that? So that one worked. And my parabola was y is greater than or equal to x squared plus 4x plus 2. So if y is 0, if x is -2, be careful when it's a negative times a negative. So 4 minus 8 plus 2, what does that equal? -2 is 0 bigger than or equal to -2. So that one also worked. So I am convinced that the shaded part is my solution to this system of inequalities. And that wraps it up. Any questions from anybody?